Now, there are situations where we want to know sine 3 theta or cos 3 theta. We know cos 3 theta is equal to 3 sine theta minus 4 sine cube theta, and cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. But what happens if we have to figure out cos 7 theta or sine 12 theta? Then what do we do? So let's look at some way by which we can arrive at a formulaic way of figuring out this. So we know cos theta plus I sine theta to the power of n is equal to cos n theta plus I sine n theta. Right? We know this. Now, if n belongs to positive integers, then let's take the left hand side. Cos theta plus I sine theta to the power of n is equal to. Now we are going to expand it using binomial theorem. So what do we get? We get nc0 cos n theta sine to the power of 0 theta, which is 1, plus nc1 cos n minus 1 theta sine theta I, plus nc2 cos n minus 2 theta times I sine theta square, plus nc3 cos n minus 3 I sine theta cube, plus nc4 cos n minus 4 theta I sine theta 4, plus nc5 cos n minus 5 theta I sine theta to the power of 5, and this can keep going on. Okay, so now let's see how we can manipulate this. So let's say equal to nc0 is 1, so cos n theta, plus let's say nc1. Let's open up these brackets of sine. So nc1 cos n minus 1 theta, and this will be I sine theta, plus nc2 cos n minus 2 theta I square is minus 1, so minus sine square theta, plus nc3 cos n minus 3 theta. Now I cube sine cube theta. Now I square is minus 1, I is I. So if I remove this, this becomes minus I. Similarly, plus nc4 cos n minus 4 theta I4 sine 4 theta. Now I4 is I square is minus 1. Minus 1 times minus 1 is plus 1. So I don't have to do anything. And like this I can keep doing. So what you will notice is that I have ended up with some terms which are containing imaginary and some which are real. So let's separate them out. So cos n theta plus, now here I is there, so I don't take it. Here I don't have I, so let's take that here. So minus nc2 cos n minus 2 theta sine square theta. Then do we have anything else? Here I have I, here I don't have I, so I can take that nc4 cos n minus 4 theta sine 4 theta and dot dot dot. Then I take plus, and I take I common out. So what will I be left with? Here I have I. So NC1 cos n minus 1 theta sine theta. Then where else do I have I? I have I here. So minus NC3 cos n minus 3 theta sine cube theta and dot 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 dot. So if you notice, for real numbers we have mainly even powers of sine, whereas for imaginary part we have sine with powers of odd numbers. Okay, now let's bring in the right hand side of the cos theta plus I sine theta to the power of n, that is cos n theta plus I sine n theta is equal to this. Okay, so now that we have this, let's equate the real and imaginary parts. So what do we get? We get cos n theta is equal to cos to the power of n theta minus nc2 cos n minus 2 theta sine square theta plus nc4 cos 4 theta times sine 4 theta. No, this is n minus 4. N minus 4 theta sine 4 theta and dot dot. Similarly, sine n theta would be nc1 cos n minus 1 theta sine theta minus nc3 cos n minus 3 theta sine cube theta. And if we take the next term as well, we will end up with nc5 cos n minus 5 theta sine 5 theta and dot 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 dot. Let's now take care of that nc1, nc2, nc3. So cos n theta will become equal to cos the power of n theta minus n minus 2 is n times n minus 1 by 2 factorial, which is 2 cos n minus 2 theta sine square theta plus nc4 will be n times n minus 1 n minus 2 n minus 3 by 4 factorial. Write this. Okay, cos n minus 4 theta sine 4 theta and dot dot dot. Similarly, sine n theta will be equal to n cos n minus 1 theta sine theta minus, now nc3 is what? N times n minus 1 n minus 2 by 3 factorial times cos n minus 3 theta sine cube theta plus, if we want, we can include the next term as well. So n times n minus 1, n minus 2, n minus 3, n minus 4 by 5 factorial cos n minus 5 theta sine 5 theta and dot dot dot. Okay, so these can be used to figure out any multiple of theta for cos and sine. Let's actually do one or two problems with this. Let's say sine 3 theta. Just blindly keep following this. N is 3 here. So 3 cos 3 minus 1 theta sine theta minus what? N is 3. So 3 times 3 minus 1, 3 minus 2 by 3 factorial. That is 3 times 2. Cos, we have n is 3. So 3 minus 3 theta sine cube theta. Okay. Now what you can do is look at this. This n is 3. So 3 minus 3 in the next term will make this entire term 0. So we don't even have to bother with that. Now 3 also actually gets cancelled. So we are left with 3 cos square theta sine theta minus cos 3 minus 3 is 0, which is 1. So sine cube theta. Let's convert this cos square theta into sine square theta. How do we do that? 1 minus sine square theta, sine theta, minus sine cube theta. This becomes 3 sine theta minus 3 sine cube theta minus sine cube theta, which makes it equal to 3 sine theta minus 4 sine cube theta, which is what we needed. Similarly, we can take up cos 3 theta. Why I am taking this 3 theta is because we already know them as an identity. Okay, so now again I follow the same pattern, cos cube theta minus nc2. So 3 times 3 minus 1 by 2 factorial. Cos 3 minus 2 theta sine square theta. Again, if you see here I have 3 minus 1. If I take the next term, remember I have to go up to 3 minus 3, which becomes 0. So I don't have to go forward. So I end up with cos cube theta minus this, and this cancels, and we are left with 3. 3 minus 2 is 1. So I cos theta sine square theta. Now what do I do? Let's take it as minus 3 cos theta 1 minus cos square theta, in which case this becomes cos cube theta minus 3 cos theta plus 3 cos square, no, not square, cube theta, which makes it 3 plus 1, 4 cos cube theta minus 3 cos, which is what we needed. So it doesn't matter what the value of n is. You can figure out the expression for this cos n theta or sin n. Okay, that's it. Bye.